All right, folks, what I want to do now is to show you how to get one last piece of sedimentary information out of this lower unit. We can do this in every other diamicton, but I'm doing it down here. Unfortunately, down here, it's the most compact sediment. You can really see once you get inside, it's like trying to dig through rock. It really is very compacted in this gray lower diamicton. But the reason why I'm digging in here is because I want to determine and use the data that shows the orientation of my class, and I want to do it in 3 dimensions. I don't want it just the azimuth, which way the class are oriented from 0 to 360. I want to know if they're up and down oriented, and if there is a strong cluster of class that are in one orientation versus more random. That's going to tell me about the till type. It's going to tell me about paleo ice flow direction at the time that this was deposited. And so therefore it's a really important part of characterizing a diamict if you think it is a till. So the reason why I'm digging in is I don't want to take any measurements from class that are on the surface and they could have just rolled and caught from below. So I need to get through that little bit of slumping, but even still I want to get in far enough so that if there is a class that was oriented like this, it may have fallen out, whereas if it's a class that's perpendicular to the face, it will be almost always stuck in. So I've got to get in deep enough to make sure that I'm not going to lose class that have long axis oriented to the face of my section. So I've dug in. Normally I would take the time and dig in about 30 to 50 centimeters to start. That way I know I'm not getting any shearing or anything like that if there was ever any sliding or mass movement of the surface. Okay, so then what I'm going to do is I want to measure the trend and plunge of a clast. But obviously a clast that is very discoidal shaped, like a plate, doesn't have a preferred orientation. So what I'm looking for is something that's more pen-shaped, something that has a clear long axis, so an axial ratio of at least 2 to 1. Some people cut it off at 2.5 to 1. Doesn't matter what the units, if it's in inches, 2.5 inches to 1 inch in either way. So we're looking for cigar-shaped or even cigarette-shaped, not to talk about all my vices, but cigarette or cigar-shaped objects, but not frisbee-shaped that don't have an axial ratio. So it's going to take a little bit more digging until I find that, and I don't want to disturb the clast. So that's no good. Doesn't have a elongated shape. You can see how nicely compact this stuff is. Okay, this one is a candidate, so I don't want to lose my orientation of that class by pulling it out. So what I'm going to do is I'm going to use a knitting needle that's aluminum so it doesn't affect my magnetic compass, or I'm just going to use a wooden skewer and I'm going to put it into the section in an orientation that's similar to the orientation of the rock, as close as I can get it. And I may, as I move the rock, I may adjust my skewer a little bit more. But oh, yeah, okay, so it's more like this for this guy. And then I'm looking at it in a 3rd dimension as well to get the plunge correctly. Is that right? No, just slightly off like that. Okay, now I'm going to put it in there fairly well. Yeah, so if you want to come over here, Rosa, and just take a look and judge my mimicking of the class orientation while I take it out. If you come on that side, yeah, right. So I'm just going to take this out. Hopefully my skewer will stay there. But now you can see that that was a pretty nice tillstone that I've got here actually. And at this point I would break it open and look at the class lithology and record that, because I'm going to do 50 of these clasts, of these orientations. But this is probably, it looks like Goldenville maybe. It's a meta-sediment. And I'll, sometimes we might keep them. In this case, I'm just going to put it here because I'm not going to do anything with it. And now we're going to measure the orientation of this. So first I'm going to do the azimuth. A Brunton works fine, doesn't really matter. The idea is to get it on top and have your compass horizontal. And right here I get, for this one, 194 approximately, 194. And now the plunge. The plunge is how much off horizontal it is. So it's plunging this way. And so I'm going to measure that angle. I could do it in a number of ways. Just going to use the inner inclinometer here. So the plunge is 16 degrees using that little inner inclinometer. So we've got 6 degrees towards 294. So to write that, you would write 16 with an arrow, 294 degrees, and that's your plunge. It's written different than you would write if you were recording bedding or a planar kind of orientation or cleavage or something. Okay, so I would do another 50 of those orientations. Some are going to be different. Some maybe show the same kind of orientation. Until I get enough data, I will never know. But luckily, we've got that data already for you. It's in your field notebook. Okay.